You know, trying to crack competitive math exams in India can seriously feel like you're staring down an impossible proof. But what if I told you there's a super clear, two-part strategy that can guide you right through all that chaos? Well, today we're doing just that. We're going to unlock an expert's guide to both the essential tools and the concepts you absolutely have to know to get a real edge.
I mean, if you're getting ready for exams like the TGT, PGT, IIT JAM, or CSIR NET, you know exactly what this picture feels like. You're just drowning in a sea of books. Which ones are actually worth your time and which ones are just, noise? It's a huge point of stress for so many students. But don't worry, we are about to fix that.
So here it is, the first part of our strategy. Let's not try to reinvent the wheel, right? We're just going to cut through all that noise by tapping into a curated list of top recommendations from a really experienced educator, Dr. Mukesh Nautiyal. Seriously, think of this as getting a special peek at a master's bookshelf.
Okay, so let's start with exams where the foundation is really that 12th grade level of mathematics. This is going to cover a whole range of teaching-related exams, things like the UP, TGT, and PGT, KVS, NVS, and the Uttarakhand lecturer exams. Now, the core content might feel familiar, but believe me, the questions can be deceptively tricky.
Now listen up, because this is where we get our first big pro tip. Dr. Nautiyal says you pretty much can't go wrong with any of those top 3 textbooks for your main study guide. But, and this is a big but, here's the secret weapon, the NCERT exemplar. He says this one is totally non-negotiable. It's where you're going to find those complex, high-quality problems that really separate the good students from the great ones.
All right, let's level up. For exams like CSIR NET, GATE, or IIT JAM, we're moving into the deep end. We're talking university-level math here. Abstract algebra, real analysis, the whole shebang. The scope is just so much broader, and the concepts are way deeper.
For these exams, the recommendations get even more specific. So, while there are a few solid options out there, the Arihant publication for CSIR NET is the clear winner. And why is that? Well, because it's the perfect 1-2 punch of conceptual explanations and a massive bank of multiple-choice questions. And for building that rock-solid undergrad foundation, the Engineering Mathematics series by H.K. Das is pretty much the gold standard.
So, look, let's just cut to the chase. If your time is limited, or maybe your budget is, and you can only get one book for these higher-level exams, this is the one. The combination of clear concepts and just a ton of practice problems makes that Arihant book the most efficient and comprehensive choice you can possibly make. Period.
Now, for those foundational BSc topics that pop up in a lot of higher ed exams, you'll often see these 2 main series in engineering mathematics. And while N.P. Bali from Laxmi Publications is a solid alternative for sure, Dr. Nautiyal gives the edge to H.K. Das from S. Chand. It's his go-to choice for really building that strong conceptual base you absolutely need to succeed.
Okay, so we've got our tools. Now for the really fun part, building that deep conceptual knowledge. Because let's be real, the best books in the entire world won't help you if you don't actually master the core ideas. So with that in mind, let's dive into a classic topic from group theory that you will definitely see on these exams, Silo's theorems.
Silo's first theorem is all about one thing, existence. It's this incredibly powerful guarantee. Think of it this way. If you have a group of a certain size and a prime number raised to a power divides that size, this theorem is basically a treasure map. It's telling you that a subgroup of that exact size is hiding in there somewhere. It absolutely has to exist.
All right, let's put this to the test. Let's say you have a group of order 100. Based on what we just learned, what's the largest possible size for a Silo 5 subgroup? I'll give you a second here. Think about the prime factorization of 100. And the answer is 25. This is just a perfect example of the theorem's power. First, we break down 100 into its prime factors, right? So that's 2 squared times 5 squared. Then we look for the highest power of our prime, which is 5, that divides 100. Well, that's 5 squared, which is 25. And just like that, we know for a fact that a subgroup of order 25 is guaranteed to exist. Pretty cool.
So the first theorem tells us these subgroups exist. The second theorem? That tells us how they're all related to each other. It says that all Silo P subgroups for a given prime are structurally the same. You can kind of think of them as identical twins. And you can transform any one of them into any other one through this special operation called conjugation. Now, this leads to a really important consequence, and it's a total classic exam question. So listen up. If a group has only one of these Silo P subgroups, what special property must that subgroup have?
It has to be a normal subgroup. And the logic here is it's beautiful. See, since all silo P subgroups are conjugate to each other, if there's only one of them, it can only be conjugate to itself. And what's a subgroup that's only conjugate to itself? Well, that's the very definition of a normal subgroup, which is a super important concept in group theory.
Okay, so we know they exist, and we know how they're related. The third and final theorem gives us a way to actually count them. Now, it doesn't just give us one exact number. Instead, it provides two very strict rules that drastically limit the possibilities for how many of these silo P subgroups can even exist.
Let's test this one out. If we have a group of order 12, how many silo 3 subgroups could it possibly have? This is a classic problem where you've got to apply both of the rules from that third theorem to find the answer.
And the answer is B. It's either 1 or 4. Let's break down why. So first, the number of silo 3 subgroups has to divide the part of the group's order that doesn't involve 3. Since 12 is 2 squared times 3, that part is 4. So our options are the divisors of 4, 1, 2, and 4. Now for rule number 2. The number of silo 3 subgroups has to be one more than a multiple of 3. So out of our options, 1, 2, and 4, which ones fit? Well, only 1 and 4. See? It's a great example of how these rules let us just zero in on the answer.
So let's bring this all home. Success in these competitive exams isn't about finding one magic book or one magic formula. Not at all. It's about a winning combination of having the right strategy and having a deep understanding of the material.
So here it is, your two-step strategy for success. Step 1. Choose the right tools. Use this expert-curated list to get the best books for your specific exam without getting totally overwhelmed. Step 2. Use those amazing tools to build real, deep conceptual knowledge. Don't just memorize formulas. You have to understand why theorems like silos actually work. The formula really is that simple. The right resources plus deep understanding equals success.
Look, we've given you the roadmap, from picking the right books all the way to mastering the concepts inside them. The path is clear, so the only question left is, are you ready to go out there and solve the proof?